Hi, ChemFam. We're back with question number 3 from dilution worksheet number 1. And as you know, for dilutions, we're looking at molarity 1 times the initial volume is going to be equal to the molarity or concentration of 2 and the volume 2. So let's look. We want to know what the volume is of a 0.05 molar hydrochloric acid solution. What volume of that can be made if you dilute it 250 milliliters of 10 molar HCl. Okay, so if we look at this, we have a 250 milliliter solution that is 10 molar. So we have those two. We know that we want to make the new concentration, so the second molarity, 0.05. We just don't know the volume. So we can start plugging in. For M1, we have 10 molar. For volume 1, we have 250 milliliters. For M2, we know that the new concentration will be 0.05 molarity. And the new volume, we do not know, so that will be V2. So when we multiply 10 times 250, we get 2,500 times 0.05 V2. We want V2 to be all alone by itself. So we will divide both sides by 0.05. That will cancel out. On the right side, 0.05 on the volume. And we will simply do 2,500 divided by 0.05. When we do that, you end up with quite a large number. It ends up being 50,000 milliliters, which is actually 50 liters if you converted it to that. But you got your volume 2 right there. Now, a couple things. Make sure that when you were doing this problem that your concentrations were both in molarity. And since your initial volume was in units of milliliters, that's what your answer would be in for the new volume as well. So that volume transfers over. But all right, that was question number 3. Let's go on to question number 4. All right, for this question, we have a 345 milliliter solution that has 1.5 molarity of sodium chloride. Now, if you boil the water until the volume drops to 250, so that means you're boiling off water, but you're not boiling off the salt, so you actually make it more concentrated by boiling it off. But we want to know what that molarity would be. So I think we're solving for the second molarity. We know the second volume, so we don't need a question there. We have that. And then we have the initial volume and the initial molarity right here. So we know our dilution equation is M1V1 equals M2V2. So let's plug in and chug out there. All right, I've got 1.5 molarity for M1, and that's 345 milliliters for volume 1. I do not know what my molarity is after I concentrate it. And how do I do that? How do I make it more concentrated, I guess is a better way to say it? Well, I boiled off some water so that only 250 milliliters are left. So because of that, there's now more moles per liter, so the concentration should go up. Let's see if the math actually does that. Doing 1.5 times 345, I end up getting 517.5 equals my molarity times 250. Now I want my molarity all by itself, so I'm going to divide that 250 over to both sides, so that now the second molarity is all alone. And when I divide 517.5 divided by 250, I end up getting about 2.07 molarity for my answer. Now remember, the other unit for molarity, capital M, this is just a recap, is moles per liter. So either way, 2.07 M, capital M, or 2.07 moles per liter is acceptable. But you used your dilution equation, and as we said, it looks like the concentration went up. It started at 1.5 molarity, and now it's 2.07. So we hypothesized correctly. Because we took away some water, boiled it off, that solution became more concentrated. We come up to the last question, number 5. We want to know how much water would I need to add to 500 milliliters. All right, so we have a volume, 500 milliliters, and we have a concentration of 2.4 molarity. So we have a volume 1 and a molarity 1. We want to know how much water would need to be added to the 500 milliliters to dilute it and make it only a molarity of 1. So first, what I think we're going to need to do is solve for V2, and then we'll compare to what it was to V1 to figure out how much we actually had to add. So that'll be a quick thing to do. But let's use our equation. M1V1 dilution equals M2V2. Remember, when you add more liquid, it becomes more dilute. So let's plug in. M1 is 2.4. V1 is 500 milliliters. M2 we do not know. Or forgive me, we actually do know. Let me erase that. M2 is actually going to be a molarity of 1, but we don't know the volume. But we can solve for that really quick. If we do 2.4 times 500, it ends up getting us 1200 equals 1.0 V2. I think we all know if we divide by 1.0 to both sides, it really doesn't change anything, and we end up getting this. A volume of 1200 milliliters is what the new 1 molar solution would be. But that's not technically what the question was asking. It was asking how much water would I need to add. So if I went from 500 milliliters and diluted it to 1200 milliliters, that means I added how many milliliters? Well, that's simple, right? Just do 1200 minus 500. So I added 700 milliliters. So to answer the question correctly, we added 700 milliliters, even though that final 1 molar solution was 1200 milliliters. All right, JChem, I hope that these dilution problems are becoming more and more straightforward. We will do more practice on it and apply it with labs and that, etc. But hopefully you have a good, strong foundation and we can build off of that. Thanks for listening. Have a great day.